Welcome, everybody. Good evening. Greetings. We're online. My name is Adam Hems, and I'm the co-leader of the Houston Azure User Group. Warm welcome, along with Tim Faddy, my fellow leader here. She's yes. So my day job is a cloud strategy architect at 3Cloud, a consultancy here in the US. And my day job is to work with clients, helping them do Azure all day, every day. And it's a lot of fun. I really enjoy it. This is actually great. I've been doing cloud. Well, I was at the launch of Azure in 2010. And I've been doing it full time since about 2012. Nothing but cloud, all day, every day. And Azure specifically, and only Azure for the last 9 years. So been doing it a little while, and this is an opportunity to share some learning with some of you, and also to have you learn from each other a little bit. So today, one of my favorite topics is container orchestrators, because this one's varying degrees of complexity, depending on how much you want to get into it. Me, this is, I'm indulging myself because I really enjoy this. Do this every single month. It's unfair to other presenters. If I hog Adam's show, so this is me treating myself. And thank you for indulging me and coming, allowing me to do something I enjoy so much. All right. So, any developers in the room? Those, yeah. Oh, okay. So this developers. I have a developer background. Do it like this. This developers. Yeah, there we go. Okay. That's it. Thank you. Okay. Infrastructure folks. Infrastructure legit. Yeah. Kim's infrastructure. Kim is an SSP. SSP. Technical specialist with Microsoft. So the day job. Hers is kind of like mine, really. You're all day long every day. Oh, me. It's a family affair. So his son, friends who were helping us out at the door there. So very much a team effort. All right, so infrastructure, security folks we got in the room. Yeah, okay, security as well. Okay, consultants. Yay, and that's common, right? Consulting. We need consultancy to everything. I work for consulting. I've done consulting for about 12 years in all. Yeah, you need to learn lots of different things. So, all right, well, warm welcome. You're in the right place. Here to learn. Hopefully, we can have a little discussion and chit chat. Those of you online can ask questions in chat, and is watching on to help answer the questions. Interaction. We'll keep it interactive. Okay. No further ado. Okay. See anything? Reading glasses. Okay. Relate. Okay. So I picked two of the actually. One on the. So there are many container orchestrated solutions in Azure. There's quite a few of them. So there's some that you wouldn't want to use, like Service Fabric. Actually, has anyone heard of Service Fabric other than Sergio? Because we worked together back in the day. Yeah, it's an orchestrator. It also supports containers now. Don't bother with that. No one uses it. It does support containers though. There's container instances. There's web apps, which also support containers. And I'll talk about that one briefly because that's a legit use case. And there's container instances. Yeah, I covered container. Then the two biggest ones, the most popular, the most powerful, if you will, are Azure Container Apps, ACA, and Azure Kubernetes Service, AKS. There is one other Kubernetes-based service, Azure Red Hat OpenShift, which is even more powerful. I'm not spending time on that one. Even more features than AKS in many ways, a bit more specific of a use case. In particular, Azure Red Hat OpenShift, Red Hat add a whole ton of stuff on top of Kubernetes, the same infrastructure as AKS. So it's like AKS, but with even more stuff provided by Red Hat. And Red Hat also provide the entire software stack all the way from the operating system, the OS underneath it, all the way up to the Kubernetes, the OpenShift services on top of that, and containers as well on top of that, the OS as well. The whole thing, all the software it has supported, which is very different from AKS, which is old source. So I've done previously comparisons between AKS and ARO. They are pretty different. AKS is the one that's prevalent because it's cheaper, basically. And so that's what we usually see more of. So being like one of the more popular of the services for running these, that's what we're going to compare to Azure Container Apps at the moment. We can talk about ARO some more if you want, but like I say, a bit more of a specialty premium, very highly featured, very well supported service, more from an enterprise, centrally managed container-based platform is what we usually see that for. So shared amongst lots of teams, central IT department who need enterprise container platform. Large swath of their organization might stand up a central ARO cluster to get all the features they might want that and operate it that way. AKS can be operated by one dev team. It's how that's seen. So tend to see small numbers of AROs at a given enterprise organization, lots of AKS clusters instead, depending on the size of the organization. So with that, and then ACA is the newest one on the block. So Kubernetes was invented by Google in 2014, I think, and they open sourced it, and it's been just taken off as a mechanism for orchestrating containers ever since Linux initially, and since 2016. Containers have also been an option. They're an option for AKS and an option for ARO and some of the other container services in Azure. Azure Container Apps is Linux owned, so you can only have Linux Azure Container Apps. So AKS, very much a very powerful Kubernetes-based service. Kubernetes is, like I said, generic open source platform underpinning ARO and on other cloud and on-premise. So you can purchase or get an open source distro, Kubernetes, variety of them, and it's the same container orchestrator. On virtual machines, you can plug virtual machines on Azure if you want. So Azure Container Apps is very much platform as a service. There is no Kubernetes at all, none of it, zip, none at all. So very much an opinionated container hosting service. So that at a high level difference between these two container orchestrator services. Once again, I haven't talked about our container instances, which are better for more ephemeral containers being spun up with your code in it, right? Spun up, stuff goes away. I talked about Azure Red OpenShift and web apps. So web apps only useful if the container is a website, because that's all they do. They serve port 80, port 443. And so if you want some sort of timer job or something else for your computer, it's the wrong choice. It's not that. It's a website, and it's also only one primary container. You can have sidecar containers and web apps now, but typically, if your application is a microservices architecture, so it's made up of different components, right? Web front end, API, other APIs, all making up a distributed, powerful system, then you need lots of containers, different applications, and a container orchestrator to manage them. So if you're using web apps, then you need to web apps do that. They'll all be websites. But if that level of complexity is what you need, then those are too small. They just don't cut it. So you need one of these two. So what we're talking about now is, all right, well, which of these two, right? So if you have an application that it's containerized, you might have written it yourself, or in some cases you purchased it from a vendor, or it's an open source solution, right? One of those. But the key here is that it's containerized, it's in some containers, and you need to deploy it in Azure, and you need quite a few of those containers, and it might be good for scalability, and your application, it might be made up of more than one container. So it has more than one service So web front end, usual, right? Might have other storage services, back potentially various APIs, listening and timer jobs, and various other components, all of which make up the microservices application, all of which are in different containers that have different life cycles, might have different teams that own and update those, but you need them to scale independently, and you have infrastructure to deploy and manage those containers on. These are your two main choices. Again, Azure Kubernetes would be a third. That one's a bit special, so we're putting that off to the one side. But between these two have such a large-scale microservices-based application that is containerized. They look at to deploy. These are the two to pick. Spoiler alert: AKS is the more powerful of these two services, netted out. But it also, with all that power, comes a great deal of learning and a bit more care and feeding. You need to know what Kubernetes is, for example. You can't just don't know, I know what container, I know what Kubernetes is, don't care. You can't do that. Azure Kubernetes Service, because Kubernetes is the core of the software stack that does all the work. You have to know how that thing works. If you do not wish to know the complexity of Kubernetes, then ACA is where it's at, because there is no Kubernetes. So that's one of the initial differences. And then, because of all the power of AKS, it has a ton of extra features. It has a lot, and we're going to go through some of those. So the question that you need to be asking yourself, again, and picking from these two, is, do I need the extra features that AKS has? Because it has way more features. And the thing I want to advise you of is, this isn't a business requirement. The business says we need whatever, or maybe some corporate IT governance, if a technical requirement, IT requirement says whatever. Public internet-facing websites, for example, and then that makes no difference to either of those two. It's a lot more nuanced than that, and that's the key to understand. You need to understand the extra features that AKS has as a technician, as an architect, potentially also as a developer as well, to understand the infrastructure that these services, in particular AKS, offers you as a developer, because the business aren't going to know or going to care. And also, I mean, you can try to explain it to them, but it's very, very niche, right? And also, corporate IT governments in general will not have the granularity to also make that decision for you either. So it's very important when picking between these services, as a technician, as a developer, as an architect, in the technical space, as an IT professional, as a consultant, with your infrastructure, security, a developer, all of those, you need to know what these services are in order to make an informed decision, right? Because one of the benefits of containers is, oh, okay, I can deploy those to a different service, and you can deploy container Azure Container Apps, and then later AKS if you need to, and that's great. A good call. But another aspect and a key gotcha is that many of the services, in particular AKS has, when you deploy that infrastructure, you choose to deploy those features at deployment time. And in many cases, you can't change your mind later and turn them on because you felt you needed it. You need a new cluster, and there's pain and aggravation there, and there's effort and hassle. So and there's also sets of features that each of these have that you might want to, in fact, you would want to leverage between either of these that are native, some native features, that also make it not as easy to move between these services. So care needs to be taken about, in particular, an understanding of what these things offer really from the beginning rather than later. Now, a common part, you could go from the easiest, so web apps again. I'll show it to you. Web apps are easy because they're simple, they're straightforward, don't have many features. They're the original, actually. They were there in 2010 when Azure launched, before virtual machines, in fact, before Kubernetes was invented, long before AKS or ACA was invented, been a really long time. Not supported containers for that long, but nonetheless, the OG, right? But very limited features compared to each of those two. And you could start there if your application is simple and migrate to the simplest of these two, which is ACA. You could do that. And then if you needed to migrate to AKS, that would work. That would work.
So,
yes.
So is it a practice that you deploy first to ACA and then figure out if everything is okay?
Yeah, that's the path I was just describing. You could do that. You could do that. That would not be wrong. It's not wrong, right? Harder to go actually from either of these two to ARO because of the Red Hat features. You want to use Red Hat for that. But between these two, that is a path you can take as long as you're on Linux, because ACA doesn't support Windows.
So ACA,
no.
It's one
right. There's a lot of things it does not support, and we're going to talk about that, right? Yes. There's a ton of things it doesn't do. There's a whole long list. I think I've got 4 slides of things ACA doesn't do, AKS does. So, but just your question: is that a migration path? Start simple and get more complicated if you need to. Yes, yep. The beauty of containers is that you can use the exact same Azure Container Registry, ACA, to store your containers in, and either of these two services will pull from it, as long as it's Linux, as long as it's not ARM64, because AKS supports that, ACA doesn't, and you'll see there's a lot of ifs, right? A lot of ifs. So that's why it is very important to understand the features of AKS and then decide early on, well, actually our application would benefit from, I'll pick ARM64 as an example. That's particular chipset, right? And the ARM chips are non-Intel, right? Not AMD, not Intel, ARM chips. They're available in Azure as virtual machines, multiple cores, a lot of cores of those. The key to ARM infrastructure is it's cheap. It's cheap. It's not as fast stuff, but it is really cheap. So maybe you don't need the performance necessarily. You're really budget conscious, in which case you can build your containers to ARM64, but that means you have to use AKS. So if you have an understanding at the beginning of your application design, your architecture, that we want to make this thing as cheap as possible, but we need a lot of the scale, for example, then maybe we need AKS. Well, we would for that technical requirement, right? But the downside, and this is again what we'll get to see, is, well, with AKS comes a lot more care and feeding. It's a beast. Well, we'll see it, and you need to understand it. So if you just wanted ARM64 because you want to save some money, but you weren't prepared to deal with all the monitoring and updating and managing and patching and all the loving and feeding and caring that AKS requires, then you made a mistake by just saying, well, we want ARM64 because we're cheap, so we're going to go for AKS, we're going to deploy to that, and then we've got all this extra operational cost that we didn't plan for or intend. We've got all these, the developers, no one cares, no one wants to maintain it, we don't have the people, no one wants to learn the skill set to understand Kubernetes and all of it.
Is it possible to have a mixed environment where some nodes are ARM, some nodes are Linux, some nodes
you can
in the same platform?
Yeah, on AKS you can. You can have a combination of Windows nodes, Linux nodes, and all those Linux nodes, you can also have ARM64 nodes.
And you can deploy specifically, okay, I don't want this.
Painting your image and what's called the node pool to a particular type. So you can have nodes that have GPUs in, for example, large honking great NVIDIA GPUs that your applications would use to do science programming and stuff like that. So you can have, in both of these services, support GPUs, AKS. You can have nodes of just GPUs. You can have nodes of just ARM64, nodes of just Windows, and you have to have nodes of just Linux. Your complexity just went up, so did your cost. But those are the features, and so that's some of the power that AKS has that ACA doesn't. It's a good question because there's a lot like that. So let's get into it. That was intended to be level setting between these two at a high level, right? Straightforward platform as a service. They're both platform as a service. AKS just a ton more features and power, which requires more care and feeding. That's good. Okay, got a build here, but you know. Okay. So all right, ACA, generally speaking, general purpose containers. So applications that span many microservices, right? Because if it's one service or one web app, it's one website, then you don't, well, I mean, it'll run on ACA, but that maybe more than you need. Depends, maybe, because a web app would do that just fine. I'll show you an example. But if you typically have more than one website, API, things like that, then that's why you need a container orchestrator, and ACA is great for that. So it runs that. It is powered by Kubernetes, but that's hidden. It has Kubernetes under there somewhere, but you don't get to see it. Don't have to see it. Microsoft deals with it. It is invisible. As you may or may not know, if you're climbing the learning curve on AKS, there is a whole very powerful command line interface, kubectl, which you'll need to learn how to use in order to interact with a Kubernetes cluster, any Kubernetes cluster that you own. It's required for managing AKS. Does not work against ACA. There is no kubectl. None of that exists. It's just not there. So you don't have to build it. It's hidden from you, which is great. That makes life simpler and easier. Instead, it does include some features out of the box. So Dapper, in particular, which actually I have. This is more for the developers. So I might. So this one, this little diagram here. It's a software tool set useful for developers. Provides it's open source. Provides commonly used platform services for distributed applications. So it's something that as a developer you'd want to use rather than have to write your own code or buy something. For common services like message brokering, caching, has various security services built into it that just are things that just microservices applications tend to need, that this software stack just provides. Now, it's open source, so you can just go grab it and install it. ACA includes it out of the box. It just comes with it. You don't have to install it. You don't have to configure it. Don't have to turn it on. It's just there, and you don't have to use it. It's just a software stack, a set of tooling that's running. Your code uses it, which it should. Yeah, because it has a lot of good features. Then away you go. That simplifies your infrastructure. AKS does not come Dapper install. Instead, it's available as a plugin, an installable addition that you choose to add when you want, and it's deployed to your cluster. There's some extra steps, some extra work that when you're deploying your AKS cluster has to be done in order to get Dapper. By way of simple example. CADA is another good example. So CADA is auto scaling software stack. So traditionally, your infrastructure will scale on the usual things like how busy are the CPUs of the virtual machine. That's the classic way of, okay, CPUs are busy, so add another virtual machine, and they scale out based upon infrastructure, and that's got nothing to do with your application at that point. Or your application might be suffering in some other way, like message buildup, for example. So even the CPUs are behind, maybe some other infrastructure component, networking or something downstream. The database might be very, very busy, but your cluster might not be. That might be because of messages built up in your application, for example. There's not a way of scaling infrastructure based on messages because there's no correlation there directly, right? It's CPU, memory, disk, or the typical infrastructure components. So CADA allows that link. You would need to use it in your software, and you should. So when certain metrics that are meaningful to your application, again, picking on the number of messages in the message queue that my application needs to, when it exceeds a certain threshold, then add infrastructure to scale it out so that message count will drop. Very software driven, right? It's not infrastructure driven. And that's why you need tools like CADA, because that is software driven, automated scale. Again, the developers should use in their applications and not just rely on the infrastructure doing all the work. I mean, you can just have infrastructure scale out when the CPU reaches high thresholds. But the problem with that is that that means that the application has to slow down and get very bogged down before infrastructure gets added, right? And adding infrastructure, spinning up additional nodes, deploying additional pods, deploying additional containers, can take a little time. And so by leveraging CADA in your software to manage the infrastructure, then you get a more scalable application in ways you can't scale infrastructure as low. CADA is included, it's already deployed on ACA. Yes, whether or not it's automatically deployed to AKS, answer no. Envoy is another software stack used for load balancing traffic coming into your cluster. It has a slew of features for managing traffic. Weighted traffic, for example, you can have certain containers have more of the traffic than the others, and there's various features and components for balancing the traffic in between all of your different applications. Also included ACA, you'd need to install that on your AKS cluster because it doesn't have it. Any questions on these first two? Sense? Go ahead.
This might be a silly question.
There are no silly questions.
You said that if you just have a single web application, then it may be good to run it on Azure
Web Apps. Yeah, app service. Yes. Mm-hmm. Yep.
Then it may be able to be run. It may make sense to run it on ACA. But then do you say once you add like a single, like let's say backend API to front end, then at that point, would you say you would generally prefer ACA over like having two web apps in the same Azure App Service?
Right. So you could, right? Again, one of the challenges and one of the reasons this is so difficult, and Azure's changed a lot, is because there's not necessarily, you could, and you wouldn't necessarily be wrong. And, again, there's 4 or 5 different container orchestrators. They all run containers, so you wouldn't be wrong by picking any one of those necessarily. So you have to have a deeper understanding of what your application is likely to do and could do. So, for example, a straightforward web app, just a straight website, and I'll actually have an example. I'll show you. Straightforward website, all it does is just serve requests, authentication, store some data. It doesn't really matter what it does, but it's quite simple. Yeah, you can run that on a web app, which does scale out, just scale out features. That's probably about it. And then you could add an API, and perhaps you should, so you're not talking directly to the database. That would be good. Add the API, just one of those behind the web app. You could also have that in another web app. An example of that as well. Got one of those. You could do that. That would work. Windows or Linux, they both scale out independently. What you need to understand about the design of your application is it going to get any more complicated than that? Or really is it about done? Anything else you need? Are we going to grow? Are we going to get more features? And so in particular, looking at things like, I mentioned Dapper right there and CADA. Are there going to be in the future? Well, we've got a bunch more APIs we need to add to this thing. We need a management website or other types of websites, a B2B website in addition to the B2C one, right? What is the roadmap for my application? Am I going to add can I see myself adding just a lot more services? I don't mean necessarily that if the website's going to have just a bunch more pages on it. Nah, who cares? No need for additional infrastructure there. Or if it's just going to get a lot more users, okay, the web app will scale out just fine. But the complexity of your application, it's going to integrate with more back-end systems. It's going to add more functionality, get some event-driven stuff going on here, going to add some AI to it. And we're going to get crazy and have lots and lots of stuff added to it. It's going to not just grow in usage, but grow in features, capability, etc. Right? So that means your application design is going to get more complicated. It's going to, and technically you could just keep adding web apps, one for every single one. But when you have a microservice application that's all on isolated infrastructure like that, you're going to run into the kind of problems that Dapper, Cater, and Envoy solve. Those are going to become developer issues for you. Well, we need a centralized caching service for this. We need security features. We need ways for service discovery. We need ways for these services to find one another. Things like that, and auto scaling via software rather than just what the web app does, which it adds infrastructure when the CPUs get busy. So the needs of your application, if they start getting into needing these kinds of features to make them grow and scale, and then you're going to need a container orchestrator. You've outgrown web apps. But if none of that is necessary, web front end just going to grow, add features, API, more stuff. It gets bigger. You can keep it on web apps until you get to the scale limits of web apps, which are huge. Long answer to a short question. Good question, though. Yes, sir.
For these custom, these open source technologies, how easy is it to test locally? Do I have to deploy it to ACA to actually test functionality?
Oh, ACA, you can't run that locally. There's no local running of Azure Container Apps, right? The components that it uses, like Dapper and Cater, you would need to install those locally. So, but in short, really, it's not very easy to. You can't run your ACA cluster locally and have that all replicated. So what you would need to do is, typically build it. Each individual application and service that runs on that thing, you develop and run that and test it locally, and integration of that needs to be done locally with other local copies of those containers running. But actual deployment would still need to happen in ACA. That's actually different from Kubernetes, which you can run that whole cluster on your dev machine if you need to. But it's huge, and suddenly you're going to, it's honking. I mean, you've got a vast amount of infrastructure all of a sudden, and so that's not a very desirable story either. AKS does have more features for debugging code that's actually running in a container in AKS, so it is better in that regard. But really, the strategy that you're going to need when you have an application that is sufficiently complex to need either of these two services is a great deal of isolation between your application. So very truly a microservices architecture. So your API and service, you manage that independently, and you own it. You have the DevOps pipeline. You own that. And Bijan's service that calls yours, he owns that too, and you share understanding of the interfaces and rev those and version them and all of those pieces, but that needs to happen independently and then deployed and managed in your AKS cluster with versioning of your APIs in the cluster. So it's a pattern of microservices development that you'll need to learn in order to break each other's stuff all the time. When you rev your stuff, he doesn't have to rev his stuff because your old stuff is still running. He has that still works. And then when you let him know, okay, to our new stuff, so you mechanisms for keeping old versions of your things all running on the same cluster, right, with different backends. And you're using services like Dapper for service discovery. So he's using those services to find yours and the latest versions of those, right? So that it doesn't, it's more flexible, it's less brittle and all the deployments, because microservice applications can be very, very, and if you aren't using some of these tools, well, perhaps that one in particular, or Envoy being another one, in order to help with that, because it gets complicated. I mean, there's the pieces in microservice applications. That's the nature of them. No big honking monolith like back in the day, where the entire thing comes up on your dev box, and you've only got multi-threading issues to have to deal with, right? But now you've got multiple services, and so it's a different pattern that you'll need to learn. And so whether you're on ACA, AKS, at that point doesn't really matter so much. They're just ways of deploying your application. It's how you develop your services and use these open source components to tie them together. That is more important than trying to get stuff running locally, if that makes sense. Yeah. Simple applications like Bejon's example could be run on web apps, website, one API, and that problem is gone. It's only in more complicated microservice-enabled applications where you need to work with that. And yeah, developing, running locally is not the way to go forward with that. That was when your microservice architecture wasn't full of. You've broken that up. You now have microservices, so different way of working. Great questions, good discussion. Yes.
What kind of event-driven application or what do you call endpoints it supports? Like, does it support various types of queues, as in like a RabbitMQ, or different types of queues, like storage queues?
That's a good question. I'm sorry, I actually don't remember. I don't remember what event-driven services support. Sorry, don't remember. Gonna have to look it up. If I click the link, then maybe it'll.
I know it supports service bus. I've used it with service bus. That worked pretty well.
Service bus.
I would think it works with RabbitMQ.
Storage queue.
Yeah.
See, so you can scale on service bus, event hubs, Edge, and Kafka. Look at the event driven, Redis being storage. So there you go. Those are what it's
Okay.
So
there are companies that use RabbitMQ.
Yes, yeah. So RabbitMQ, you would need your own container of that. You'd put a container of that thing. You'd add it to your cluster, and that would be your messaging service. I'd ask, okay, and that's not wrong. That's okay. What you really want to do, though, is migrate from that, which would work just fine, to a native Azure service like Event Bus or Event Grid. Event Grid being native platform as a service eventing in Azure that has the features of RabbitMQ and it solves the same problems, but you don't have to run it in a container. So does that answer your question? Short term, yeah, RabbitMQ, fine. Put it in a container because your application needs it, because somebody, back in the day, what is on-prem, right? Fine. Then yeah, that works. You can stay that way if you want. That would also be fine. But generally speaking, hand wave, you want to move to platform as a service, right? Leveraging services that Microsoft do for you, so you don't have to run them on your ACA cluster. Maybe you can get rid of that one, and perhaps another one would be Redis. That's another common one. That's common in containers. That's a caching service, right? So if you want to speed up access to your RDBMS, your SQL database, you can put a Redis cache, high-speed in-memory cache, in front of all the requests to the database to speed up your application. Common one, open source, works just fine. You can get that as a container. Also runs just great on Azure Container Apps. So you can have a Redis container and a RabbitMQ container, and those would both work just fine. And your website would use both of those. That'd be great. Better to delete both of those, recode to use Event Grid for eventing, and Azure Redis, which is a separate external service.
It's a caching.
It's a caching service. So as Azure Redis, it basically but it's a separate service, separate piece of infrastructure, doesn't run in your cluster, it's external. You would stand that up separately and use that instead of having it running in a container on your ACA.
So that would recognize a change in the state inside database and it updates and get triggered.
It doesn't. Venting against changes in databases is another topic that depends on the database. Cosmos has native support for emitting changes. SQL database also has some support now for emitting changes to services like Event Grid that you can then use to trigger code running in your containers elsewhere. So you have a few native Azure options for that, which mean you don't have to have containers on your ACA or AKS, which is really what you want. That's what you want. You want as little custom code as you want. You want as much platform as a service as you want. And yeah, it's common to start with all these components because when you're not in Azure, you don't have them, right? When you're on-prem, RabbitMQ is what you've got. So Redis cache, that's what you've got.
Yeah.
But you want to migrate a long way from us. And then event-driven architectures, can be enabled for your custom applications using ACA, like we say, using the Azure native stuff, not RabbitMQ. Is to move away from that, so you can leverage the platforms of the platform features to make your less code, et cetera, et cetera.
Thank you.
Yeah, good questions. How does people use the board? I mentioned that. Kim has a question.
Yes. For latency sensitive workload that are in a hybrid setup, would you recommend? What kind of architecture design would you recommend in terms of leveraging, Azure for scaling? So I have a hybrid setup where my Kubernetes cluster is running on-prem.
Okay, Kubernetes on-prem, all right.
Right, and this application is sub-millisecond sensitive in terms of latency. So what would you recommend? I'm excited to see Kita for scaling. So if on-premise are very, very busy, ideally we'd like to offload some of the workload to the cloud. So I'm wondering, what's some of the best practices for latency sensitive workload?
Latency sensitive between on-prem and Azure on either of these services.
And what did the jump from on-prem to cloud get you out of that? I mean, that deadline is not going to work there, right? Like you're not going to get sub-millisecond response there.
Right.
That's going to depend on network, express routes.
Exactly. So if the latency is between cloud and on-prem, and that's your problem, then that's just a networking problem. I mean, speed up your network, go for direct Azure Express Route Direct for the shortest possible path, fattest pipe possible. That's just straight networking. And that doesn't make any difference between any of these services here, really. What you really need to do is migrate the latency sensitive components from on-prem to Azure and keep them together. You can't have a latency sensitive application that's spread between Azure and on-prem because of that distance. Unless you've deployed your application to somewhere physically close to where Azure is, like here in Dallas, for example, in the Equinix data centers, that's particularly close to where Azure data centers are, so you can get lower latency with that, for example. So you put infrastructure in that physical location on-prem in order to reduce, that just reduces the network path. That's all that really does.
Right.
And so that's really all that you have when you have a latency sensitive application between Azure. Just reduce that networking time. I can't think of another software tooling, or certainly either of these services, any of the container services that really help us in that regard.
But you could have a latency issue because of compute power, in which case it makes more sense to have it in the cloud where you can spin up more compute power.
That's the scale out story.
The scale up, right?
So,
We
yeah,
got two-
yeah. You know, so scaling out should be quicker in the cloud, container, even quicker and more application specific, more relevant, right? So rather than wait for the CPU to get 8%,
Yeah.
scale out what needs to be.
I'm sorry, I didn't mean to put you on the spot, but I was thinking out loud, you know, it's there are many player dependency in an application altogether in terms of logic and how it workflow, right? The database on-prem and where is it in terms of proximity to the orchestrator, and the you know, solving the application logic has to be together as one unit, and you're absolutely right about the location should be all together.
Yep.
And all of that dependency should be cohesive and beefy to be able to work together as you know, in scaling out and into Azure or on-prem as well, not just so.
Yeah, so like, you know, a database on premises and then either of these AKS or ACA services in Azure is not going to be a good thing unless they are very managed to really, really reduce that networking or use a lot of caching. That's just not something you want. It's just not going to be a good story. The database needs to move with the Kubernetes cluster. Until you can move both of those things, it's not going to be good. There isn't really a good answer to that.
Thank you.
Yeah. Okay, I mentioned GPU before, so yay, it does that. You can have that. Not all the containers is there. So picking on our friend web app, classic old school, doesn't have that. Right.
So you mentioned the built-in authentication.
Yep.
Is that is that for the every endpoint they place on containers? You like that's actually authenticated against AD or something? I mean, how exactly?
AD, Azure Active Directory, now called Entra ID for some reason. Who knows? But yeah, Entra ID.
Yeah.
Previously known as Azure Active Directory since 2010. Entra ID is the identity provider that you would want. It supports as a built-in authentication for. So what, you know, so AKS doesn't have this, right? Web apps does have this. So just very quickly, the problems that this solves. You have a website, and you want to provide a mechanism for users to sign into the website. That's obvious. Or maybe an API. You need a mechanism for humans to provide their identity via Entra ID and two-factor, whatever else you want on there, before they can access the content of your website. Straightforward, security need. Two ways of doing it, and the classic approach is, well, that is the developers. The developer, good luck, crack the knuckles and write the code in the website to include that authentication. Good luck. There you go. This toolkit, basically, it is the developer's problem. They have to do it. Enjoy. Or this actually provides it at infrastructure level. So it means actually the developer doesn't need to do it, or maybe they didn't do it, or you don't want them to do it. No matter. In any event, the infrastructure can do the authentication so that the developer doesn't have to, or because they didn't, or because they can't, or whatever reason, right? And that's better. And if you plan for it, you plan in your application design, don't build in authentication. Then because we're going to use the infrastructure to do it, then that reduces the amount of work the developers have to do. They can just focus on more interesting, fun stuff than very tedious, boring writing against libraries against Entra ID. Eric.
So that's just Entra ID support for the web applications?
That's a good question. Definitely supports Entra. We'll have to go look to see if it supports any other identity providers. Not sure on that.
Because then the follow-up would be, does it also support workload identity?
No, it does not support workload identity at all. We'll get into what workload identity is, because that's a good question. Yep, one of the gaps does not have that. So this, to be very clear, is authentication, typically a human in front of your web app, just usual sign-in, right? There's levels of authentication and security between the containers that you might also want as part of your application design. That's your problem. This is not solved by that. This simply the front end. So nice to have. Web apps also have this. AKS does not have this. So your developers absolutely 100% have to write the code for the authentication. If they don't, it's not there. Unauthenticated web apps, no one wants that. So more work for your developers. And that's another thing that, as part of the journey going from web apps. So web apps have built-in authentication. Yeah, we just enable that. Don't write the code. Quick. We can get to Indicator and still use built-in authentication. Yay, didn't have to write that bonus. That's awesome. Migrate all the way to AKS or Azure Reddit OpenShift. Missing, not there. Not a feature, can't enable that. Cannot deploy my application to those services until we go back to the development team and say, well, we need to add authentication to it because we were relying on infrastructure to do that. We've migrated to a new service that lacks it. So again, this is one reason, very important reason why you need to understand what your application can do, will do, should do, will do in the future, what you want it to do, and what these different infrastructure services support. Straightforward website, great. Let the infrastructure do it. More complicated, if you're going to need something like AKS, you cannot rely on this infrastructure.
Does it provide all the other capabilities such as cross-site or
support, things like that?
Yeah.
ACA supports core support. Yep.
It does?
It does. Cross-origin resource support. Yep.
Like pretty much like an application gateway.
Application gateway is a feature that is well supported by AKS specifically. So those two go very well together. And application gateway is a layer 7 of a networking stack load balancer. In particular, has some security features that are best suited to websites. So it is a very powerful front end to internet-facing websites, and you want one of those. It's a good thing. Very, very secure, powerful infrastructure that is recommended in front of AKS clusters specifically. AKS supports using those things, not available in ACA. No support for at all, nothing. You can put an application gateway in front of your Azure Container Apps if you would like, but you have to do that. AKS will actually stand up the application gateway for you if you would like it. So that's actually another big difference between those services. I actually don't have that on my list. So that was a good one.
Just going back to the built-in authentication real quick. Can that be configured through CLI or Terraform, ARM, or Bicep?
You can. Yep. Can and should be. Because how else would you do it? A rhetorical question. But you would do it is not in the Azure portal.
That is.
It's not in the Azure.
Okay.
It is never in the Azure. Azure portal is great for demos. I'll show you a demo where I'll use the Azure portal. That's the only time anyone should be using the Azure portal. Do not use the Azure portal, except if you're looking at infrastructure. It is the best solution for reviewing the state, monitoring, analysis, the settings, the configuration, the health, all of those things, cost, all of that. Use the Azure portal. Look at everyone, developers. It's not just it's for everyone. Business, everyone should have access to that read access. It's fine to understand how the infrastructure is performing, costing, all of those things. You do not use the Azure portal to create anything ever. Now you can. Don't.
Ever. Except the first time you created a portal so you can figure out what the IAC should look like.
Yeah.
Ask them now.
Say there's an old.
How do you really want this to work?
Yeah. I've seen sometimes where they have certain features in the UI that's not necessarily available.
Absolutely, that does happen. Yes, yeah, but it'll catch up. There are often features in the CLI that are not lit up by the portal because they're built by different teams. It's all APIs underneath, right? Infrastructure, then APIs. That's the order in which it's built, and then the CLI is built separately. The website is built separately. Form support separately. Bicep support separately. It's all different teams on the same set of ever-changing APIs. The core is the APIs. So, yes, I wouldn't recommend creating a resource in the portal in Azure and then exporting the template. Don't do that. If you want to be lazy, you should. You should always have a developer. Best developers, in my opinion, are those who are lazy because then you go to a great deal of effort to avoid writing too much lengthy, boring code. So another way of being lazy in the world of Azure, in particular with infrastructure, is code. Any guesses? What, other than creating it in the portal and then reverse engineering it?
VS Code templates? Or...
Nope.
Bicep now they have, so maybe a year ago they didn't, but now Bicep has bigger template sets, like best practices and whatever the word, the 3-letter.
Oh, ACD?
Not ACD. Well, ACD is another one, but
So CLI.
Bicep has the common libraries now, basically.
It does. That's
How
right.
do you orchestrate the thing? How do you make the resource in a way that actually works?
Yep.
Versus like technically it deploys a resource, but it's not functional because you forgot this setting or that setting.
My tip for creating boring infrastructure as code templates and not using the portal at all is to learn how to use Copilot in Visual Studio Code. Ask it to create the templates, because guess what? It does. It'll create the template for you. Create me a template that creates, in fact, most of the demo I'll show you, most of the demo I'm about to show, I created using Copilot rather than Copilot. I didn't once use the portal to create a resource and export it. Well, not once. The whole thing created with Copilot because that's less effort.
Think about Azure for Azure.
Yes. Microsoft Copilot is an all-encompassing AI with features and capability, almost everything. Office 365 has it. It's its own thing. It's an own, Copilot. It's Copilot in GitHub. Its services everywhere, but it's Microsoft's AI, and you can get that AI in code.
Visual Studio Code.
It's in AI. So it's lit up Visual Studio Code by GitHub Copilot.
Never used.
Yeah, and we can have a demo of that if you'd like. But yeah, that's. So still, the answer is still do not use it. There's still no reason to use the portal. Anyway, we got off track there, but that's it supports running command and schedules and driven jobs. So it's a common use case, right? You've got stuff running in containers.
And you gotta ask questions.
Questions back there?
Oh,
Which if Copilot gets it wrong, you won't know.
Yeah. Well, you'll find out when the
When we try to
template
deploy
works.
it.
Yeah, you'll find out. That's happened to me. It's happened. It happens. And then there is actually an Arc-enabled video of ACA. It can run. So it can run on Arc-enabled Kubernetes. So Arc-enabled Kubernetes. So I mentioned that Kubernetes is an open source container orchestrator. You can just go and buy one or download one, install it onto hardware that you own, VMs that you own on-prem. I've got one on some Raspberry Pis. I've got 3 Raspberry Pis, and I have a Kubernetes cluster running on those 3 Raspberry Pis. That works slowly. Actually. It works. It's not, even though I've got a Raspberry Pi 4 with 8 gig of memory, it absolutely works slow. It's not. So I could, if you want, put what's called Azure Arc on that, which is a software component Microsoft provides, which is an agent basically that will connect to Azure, and then you have a management plane of your on-premises or AWS hosted or wherever it's hosted, doesn't matter. Kubernetes cluster in Azure. It provides you some management capabilities. You can you can deploy things to it. You can set policies on it. There's a few things you can do to control and manage your Kubernetes cluster via Azure Arc. On that Arc-enabled Kubernetes cluster, deploy ACA.
So what kind of business continuity or disaster?
So in an Arc-enabled Kubernetes cluster, that's your problem because it's you own that because that's your VMware cluster. In my case, those are my Raspberry Pis, and if it breaks, that's my problem, right? So it's 100% the on-prem story of it's your problem, you deal with it, right? Because it's purely for on-premises. What Arc enables is the ability to see that on-premises Kubernetes cluster and do some management of it. But the infrastructure, that's yours. Assume some connectivity to the internet, but that's about it.
kind of along those lines, the control plane for ACA, is there like a production tier versus a development tier that you can have, like, make sure you have a certain amount of uptime or supportability?
Kubernetes does that. Are two different payment mechanisms for ACA, but is no, it's simpler than that, more akin to web apps, really. Yeah, two tiers, and you pay more for a few extra features, performance features, less noisy neighbor, things like that. There's a consumption tier basically, and there's a more dedicated tier, so you get more reliable performance, et cetera. So get a bit more for your money, but there's no there's not a premium tier necessarily. It's just two different mechanisms of paying for the same service. So it's much simpler for ACA. So the reliabilities does support availability zones. Both services support availability zones, so you should use that. That requires availability zones are different physical buildings in the same Azure region. So here in South Central US, different physical buildings spread in Texas, right? And so you get 3 at the most, and no more than 3, up to 3. Deploying in a zonal Azure app, you get 3 instances of each of your containers, each of them in a different physical data center. No bounds across. So that provides 3 times the cost because you've got 3 deployments of your container, but you have reliability such that the loss of one physical building will not take down your application because the other 2 will keep running. So that is both AKS and ACA support that. You want that. You should have that high availability for your production workloads. Both services support it. That's not a premium tier thing. That's just a feature select. I didn't call that one out because they both have that. Let's have a quick look at one. I've got a few slides of all the gaps, but before I do that, let's have a little look at this infrastructure. If anyone has not seen it, there's my Kubernetes cluster. Let's go find that. My to-do app right here. I wasn't going to show the code because asking about some of these templates. This one, see all this bicep right here. So this is the infrastructure as code used to deploy a whole set of infrastructure right here, including so I have 2 container apps, and so there's actually quite a bit in this one. But this application consists of one website, one API against a SQL Server database. It also has readers to cache. So I've actually got this same application. So let's look at the containers for that. Here's the container registry. So in this, I'll 2 containers, just 2. New API and new app. That's the API. It's a to-do list. So we have recap. So 2 containers. So we have quite a few options of deploying our 2 containers. We'll start with the simplest of these, which is a web app. There is the website right here. This is a straight Azure web app. Which runs, we've got a Linux container in here. We could have Windows with relatively straightforward and simple feature set. Really, the only way we know this is actually got a container deployed to it is we need to look at Deployment Center, which has been configured for a single container from a container registry, and it pulls down that one lonely container. This is a web app, and this works just fine. I mean, it doesn't have it. We can configure the authentication on this one, and for Azure Container Apps. It will do auto scaling, but not a ton else really. I mean, it's great for hosting my one website in here, and it works. We can set it to scale. No other special features really. Good place to start. And then we have another one for the API right here, which is exactly the same. In fact, it uses the same infrastructure behind it, the same app server plan, same container, same registry to do it. Yeah. So this works fine. It works great. No problem. Great. Because it's straightforward. Just click it, deploy it, stand up, and there's our website, and we can do a sign in right there, and so on and so on. So this, in this particular two-tier application, website and API, work great in web apps, and then we can also deploy them in container apps. Do it. So I have a container. So container apps is a container apps environment. So this is the compute, if you will, and there's quite a bit more complexity already on this guy. This one is configuring for, actually, well, not too much on this, a little bit more than the web app, but this is configuring the infrastructure, basically. We have whether or not it's front end. So you can see it's got CADA deployed, whether you want it or not. There it is. Did I ask for it? No. Do I use it? As it happens, I don't. But I should, really, because it's there deployed for me, and it works great. And then also Dapper also installed on there automatically. And so this is the base infrastructure, and there's not a ton else really. This thing, really. Dapper components, we can configure some stuff there, but the actual work is done by an individual container app. There are two here, one representing, again, my app, and then another my API. Look at these, and not a huge amount that can be configured here. We can control, here's the authentication we can configure, and actually to Garo's point, let's see what identity providers we can support. Oh, there, it actually supports lots of identity providers. Garo's question. So lots of options for using all kinds of stuff. You name it, actually, including Entra at the top, and then a whole bunch of everything else, all done in the infrastructure. That was a good question, Garo. We could use that to do our authentication, but in my example, you can see I've got a little sign-in link here. I did it all in code.
There's no Okta.
Okta would be the identity provider. So you can have Okta if you want. Add identity provider, and Okta would be this OpenID Connect one.
Are they?
Okay, so let's see what else we've got. It has native features storing secrets. Securely storing connection strings and passwords and things like that. It's a native feature of this service that you can and should use to store those things. AKS also has the same capability. Web Apps does not. It does support reading directly from a key vault, but otherwise it's just environment variables. So that's a native feature that this has. So does actually AKS. AKS is a little more powerful. Supports custom domains, so you can add your own domain in here. AKS does not support custom domains. You can add them if you want, but this one is a bit more like web apps. There's the Dapper features that you want there, and I actually don't know what is. I don't know what this service is. I need to look this one up. This one sprung up since the last time I did this. I don't know what it is. So. Yeah, look it up.
So if you add identity, will that support for all the containers inside?
No. So there is two components to Azure Container Apps. So I started off right here, which is the Container Apps environment. This guy, Container Apps environment. You require one of this engine. This is the horsepower. This is actually what you pay for. One, you can either pay for this one. This one environment type is consumption. You can get a other dedicated, I think. So this is the lowest cost, pay per use. The dedicated one has more capabilities. It's more of a premium SKU. But this is really what you pay for. And then you add containers to this thing. Each container is in the form of a container app. So each container app you configure separately because they're independent services. You have lots and lots of these, lots and lots and lots of these. And each one, so I was just going through first of these. This one is the website. I've got a website, I've got an API. So this one is, so this configuration, but so the identity for this one, oh no, authentication, what I meant to say, is configured just for this.
This one, okay.
It's independent. Yeah. Each container is different. So you can, and that's the point. If you need it, lots of containers, each application can be multiple copies of the same container. You can have them scaled out, but this is separate components, separate different applications, different code bases.
Yes, thank you.
So if you want identity in front of all of your containers on your applications, on your ACA, configure authentication for each and every single one of the container apps.
Then you have to add all those identities in your database, or?
No, this is the front end. There's no connection of any kind to the database here at all, right? So authentication will provide the ability to demand the user log in against the identity provider and provide back a token to your code, and then you're authenticated. What it looks for is a bearer token on the HTTP request. Find one that it redirects to Entra or your identity provider. You go and get one. Sign in. Once you've signed in correctly, it'll come back, and then you're going to have a bearer token on every single request to your web app, and then it's going to carry on. And then it's up to your code what to do with that bearer token, right? Put the claims on that thing to see what you're entitled to do, and then up to your code to figure out what to show the user. They use it, what database they use, or however. That's completely nothing whatsoever. This does it demands that the user sign in with an identity provider that you've configured it.
Gotcha.
That's what it does for you. So it does the authentication. The authorization is up to you, the developers of the application. That's their problem.
So you can include all the roles.
Right. Yeah, and this doesn't do the roles. Doesn't care about that. It'll authenticate with Entra. Entra has the roles, and they'll be assigned to the user and passed back with the bearer token. And there's up to the code to figure out. Well, they've got this role. They're allowed to see this. But that code won't execute if you've enabled this authentication. It's never going to happen. So they're never going to be unauthenticated users if you've configured the infrastructure to demand that they log in first. Gotcha. And if you don't use this, then you have to do all in code. Developers have to do the whole thing end to end.
Yeah. What about scale outs?
So we have scale options right here. So minimum replicas. So a replica instance of a container, right? So remember, there's two applications on my Azure Container App. I've got a website, which I was showing you, and an API behind it. Two different sets of code base written in different tech stacks. And a replica is a copy of one of those applications. So in this case, we're looking at the web app. And so we can have a minimum of, we can set it, in this case, one replica, one running container, up to three running copies of my web app running, and they will be load balanced automatically.
So you can actually configure your, based on your demand, you can configure it.
Yeah, you can configure the scaling. That's what this section down here is. Figure the scaling of this thing. And there's various types you can go through, including queues and custom. So this is native, right, to ACA. And depending on how you set this up, it will automatically add replicas depending on how that scaling is configured. So automatically scaling out, or in the case of queues, right, that's the software-driven features, right? So as messages appear in a queue, external application, you can have it add replicas, because we know if you write the code that the code running in my container shoot through all these messages, and if I get more of my containers, then I can get the messages quicker and do more stuff. And that might not use a lot of CPU or anything else, for example.
Gotcha.
But I can use
That's depending on your queue depth. Like you can configure, okay, have like 100 messages sitting.
like a 1,000, add another replica, or the queue gets to 10, get another replica, whatever we want. And we can, that maximum replicas can be up to 1,000. We have 1,000 instances of a container running on the container apps instance at the same time.
That is set for 1,000. Max is 1,000.
1,000, yeah. Maximum replicas of one container, of one app.
Yeah.
So that's huge.
That's pretty big. But in case if you have multiple locations, does this take care of based on location requests?
Nope, absolutely no location whatsoever. This is all in the same Azure region that I deployed it into. So this is all happening in the same region.
So you don't have a way to configure these location-based requests, like if
this service does not offer any location services at all. The front end is deployed to one and only one Azure region. You can deploy it to different availability zones. I didn't configure this one to be in different zones, but it would be a minimum of 3 replicas if it was. Yep, that's all in the same region, and it does that for you. That's just high availability. But if your user is in Australia, and you've got this one in West US, and I think this one's actually in Canada, I think that's where I put it. Just these. Yep, I think it's in. Yep, this one's in Canada. And your users in Australia, there's no mechanism offered by Container Apps to redirect you to a nearer Azure Container App. Nothing. No. You need another service like Azure Front Door in front of this service. Have your users use that, and that service will redirect to the right Container Apps instance.
Gotcha.
Yep. So Container Apps doesn't have that. AKS doesn't have that. Web Apps doesn't have that. The only service that does have that is Azure Static Web Apps, which actually does have that. But that is container hosting web service. We're talking about containers. So that's the only service that comes with Front Door built in into the premium SKU, and low balance traffic, depending on where your user is, out of the box.
What is that service you mentioned?
Static Web Apps.
But no other one.
Azure Front Door.
Front Door will do.
Azure Front Door is a global regional load balancer. So it's a global load balancer. So it also supports caching. Okay. So you put behind an instance of Azure Front Door so this is my Canada East deployment. I'd put my New Zealand North deployment and my Europe West deployment all behind the same Azure Front Door. And that front door gets a brand new URL, adamsawesomeapp.com. And then depending on where my user is, I'll redirect to the one that's closest.
Okay. So is it like GeoDNS or
it's latency based?
It's latency based. Yeah, latency based.
Yeah. Which is usually going to work out to something geo related, but not always.
Right. Yes. In theory, if it seems to be a low latency near you, then probably closer. Unless you're using VPN or something funky and using things. Yes.
Why did you choose Canada?
I chose Canada because this particular application uses OpenAI, and OpenAI is a limited resource. I can more often get that resource in Canada Central when I'm deploying my demo. Good question.
Does it have any geo-replication type of thing, like to take care of, like if the region is down, how exactly you transfer your load to, or
if the region is down, Azure Container Apps is also down. This whole thing, so Canada East, Canada Central in this example goes offline, then this Container Apps instance also gone until Microsoft bring it back up. It's out, gone, and Container Apps has no features to help with that. Neither does AKS. AKS does have, it has another service you can use to help with that a little bit, We'll talk about it. But container apps, nothing at all.
So is that
Another one in another region, and you need a front door in front of those two. And then when this one goes down, Azure front door will notice there's nothing in Canada Central anymore, even though people are in Canada. So latency says that we should serve them this one. So it's gone. So we'll serve them the other one that's still up. And you need that in that case. Container apps.
the developer would have to take care of those? Like you have to have a readily available service in some other area, and
You need another instance of container apps and everything it relies on, right? So in this case, what do we have? What does this thing need? This has a redisk. It has key vault, which has geo redundancy features in it. So we probably wouldn't want to rely on that too much. And we would use the sequence features of our container apps in that case. Application insights, it's global. We don't need to worry about that one. SQL database, absolutely need to worry about that. Fifth is locally deployed to Canada Central right here. And I would need a rep of this database in the other region. Container apps doesn't help at all.
yeah. So since it's a compute, I mean, you can always probably have a geo-redundant database somewhere, and then connect that.
That's what you'd need. I mean, you've got a few options, right? You can just use infrastructure as code to stand up another copy. I'll show you bicep files for this thing just now. Easy enough. Takes about so the container apps one is this one. This is the container apps infrastructure as code generated using Copilot, incidentally, which is Copilot. Oh, it's been moved. Okay. We're here now. Okay. So
It's up there at the top. It's good. You know, like supposed to.
kind of down, that moved to down here, right?
The Copilot icon is up there at the top.
Yes, the code mark that I'm using is down here, and I can create for
Yeah.
you're asking, the lazy way of doing this. It will reference my existing code, but see how it's just spitting this out. See that? And I'll just show all of this right here. Still going. It is. Look at all that. There's one Azure Container Apps, like that. All of these, this bicep right here, all of this, I create all this stuff. So the lazy way of infrastructure as code to create all this. Anyway, that was nothing to do with AKA or ACS or to the availability question. Create some infrastructure code using Copilot. I'm just saying it into your repo, and then you just deploy this infrastructure to another region in the event. Now, that means there's going to be an outage, obviously, but it's cheaper because then you just wait for everything to die, all this infrastructure code deploy to another region, and carry on. So that is very cheap, but means you're going to have an outage. That's a business decision. Yes. And it's a risk tolerance, right? If you're using availability zones in the region that you like Canada Central right here, the risk of your application going, given you've got availability zones, is lower. Not gone. It's not zero. It's non-zero, but it is lower. And the cost of just maintaining infrastructure as code for deploying to another region, in the instance this region and all three of its zones go out, is almost a very, very, very low cost. Much lower than having a duplicate of everything running in another region on the expectation that this other region will fail. That means that your risk is lower still of having an outage, and that's a business decision. But your cost is much higher because now you're paying for everything twice. You also need to all the data, and you've got more to monitor and all that to deal with. So business, if you like that, key to understand, ACA doesn't help. None of these services, well, some of these services do help. So the data sharing has the ability to be deployed to another region. It'll do all the replication for you. So will Azure Container Registry, it'll replicate the containers to other regions for you. Azure Container Apps does not, AKS does not.
How far apart are these zones? You know,
What is some of them are buildings are literally proximate and literally next to each other. Others they're in the same like city, like in Paris, for example. There's the three corners of the city. They're in the same city, but the suburbs of the same city, for example.
So,
Close.
in case the
Miles, I think. I've checked documentation. Not that far, and next to each other in some cases. Yes.
in case of a lot of settings that need to be done on any of these Azure resources, does this Copilot, if you ask it to clone exactly some of these services, to write a code to clone some of the services, will it actually look into all the settings and it will actually create all those code?
You don't need Copilot for that though. The bicep extension in VS Code does that. or actually not. So if you have a resource that exists, there's an extension in here that you just put in the resource ID and it'll just pull down the.
You can pull out all those.
It'll pull it down for you. Just generate
Why is that actually bicep extension?
Yeah, so VS Code has a bicep extension, which gives you the content, like all the telesense and all the fun stuff.
Okay.
So that one does have the feedback, so you can just do the.
So the bicep extension being.
And then you need to provide your resource and.
What you do is you log in Azure, and then there's a command that lets you import a resource, and you just paste the resource ID.
Okay.
And then your full resource ID, like /this, that whatever.
Yeah.
It'll pull it down from your Azure connection. But the portal also does the export, and I think the preview portal does Terraform now.
Don't do that.
Yeah.
Don't do that. Sorry. Yeah, the tool that Garo described. I'll demonstrate what you do.
Why?
Because not through
Resource visualizer like this. Paste.
So you don't. So it
Or
has
templates, don't do this.
we get every settings in there,
not every setting. So
but some.
it does most, except when it doesn't.
I see. Gotcha.
And so that it'll kind of like sometimes it'll do a weird output. It'll say like, I couldn't get it all, but I got some of it. There's some pieces missing. Good luck.
Yeah.
But the problem with that hides a lot of settings as well, right?
Then you want to try and then.
Well, this gives you everything like as a literal.
Yeah. On big giant, see ugly,
Yeah.
scruffy, horrible template. Don't do it.
Oh, yeah.
Don't do it. It's disgusting. Don't do that.
The right approach is to so Bicep now has what are called Azure Verified Modules. I remember the word AVM. So AVM is basically the patterns of how you should deploy Azure resources with Bicep, and it says, okay, container app, you need these 5 pieces to make it actually work, and it gives you all those parameters and all the things that you need correctly, and then you reference the place where AVM is deployed, and then you just build off that.
Okay.
So it gets a little easier.
You can probably combine that with your DevOps and configure.
Yes.
Right. Should be. I'm using Copilot to tell me how to convert this template that it created for me to use Azure Verified modules, and it's answering the question. It's doing it for me. So, thing to know: use Copilot. Yeah, use Copilot. It saves a lot of effort.
Bicep's using the same mechanism that the portal uses, so it's
Is it?
not great.
Okay, let's see what is there anything else on container apps. So we can look at biceps and some of the differences. So, that's my database. So yeah, we've got some, some basic features. So authentication, we can control some ingress in here, but it's very, a reasonable set of features. Not huge. We can make it private, which is good. We should do that. Domains built in Dapper right here, no workload identity. It has an identity feature, which is identity for the container app. So you can use identity for each container like this. So this will be the closest to workload identity error, because this is one application. So you'd have assign it either a system assigned or user assigned identity for that application, and then your code in this container can use that in order to authenticate to these two.
I was reading a little more into, so you can, with the user assigned, you could do like init level versus main versus some other, like there's a lot more detail if you go to user assigned. You can assign multiple identities and then give them different.
That's right. So each of these, so I have one on this one. This one has a user assigned identity. I can add multiple, and this identity I have set the permissions that I want on this one. And this particular one, let's see. Read can actually, so the purpose of this one is to write to application insights as this identity rather than using the connection string. So just for funsies, that's what monitoring metrics publisher is. My code uses this user managed identities permissions to write to application insights instead of using a block function key. It could also, I thought, I guess. I don't. It doesn't evolve or anything else. That's all I needed. But yeah, to the point, you get permissions to databases. It needs to read from and anything else. It doesn't. It only needs to talk to an API. It doesn't have any other permissions. But I could give it other permissions right there. Okay, there isn't much else to this service, really. I mean, there's not much else it does. Actually, scaled in and out. You can put some stuff on. You know, you can create a set for it, and kind of it. All right. So let's. So we're going to have a very brief look at my Kubernetes cluster. Just. Cluster. So this is much more of a honking beast. There's a ton more stuff. So we've got all manner of configuration settings and node pools off of here. So we can have multiple node pools, different virtual machines. A number of these is a whole virtual machine. Mount these to a VNet, two VNet ones, ones, Windows ones, constant ones, different sizes, configured to auto scale, all of these things. And then all these Kubernetes specific features, which you need to understand what these are. I'm not gonna go. My point is just to give you a feel for the complexity of this thing. Right? I'm not going to explain all these features because we will be here for a really long time.
Yeah, is Azure Container Apps hides all this, right?
Yep, it sure does. So, which is a two-edged sword. It hides it. So if you needed to have control over namespaces, you can't. It doesn't have that hidden. Would you like that? If the answer is yeah, I absolutely have to have that for X, Y, Z reason, then Azure Container Apps can't do that. That's a design decision. You need to have been planful about that. You need to know what namespaces are in Kubernetes. Number one, why you need them. Number two, and then how to use them. Number three, mechanisms for managing those in a Kubernetes cluster. Kubernetes operators to control that. There's a whole set of stuff, and that's namespaces. That's one Kubernetes feature. No?
No. So this has pretty much everything that what Kubernetes provides. Right?
Yeah, this runs Kubernetes, the whole Kubernetes stack, all of it, and a bunch of stuff.
So you can run pretty much all those Kubernetes commands, like
yes, yep.
Right commands.
Yeah, download kubectl, which is a
kubectl,
command line tool for Kubernetes, and connect it to your cluster, and have at it. Create namespaces, kubectl, namespace, create, whatever. Type that, enter, bang. Yeah. All of that power, all of that control you have with this. Of course, the rhetorical question is, do I want all that power and control? Do I need that? Do I know what it is? Do I know what namespaces are? No. And actually, I mean, again, how complicated is my application likely to be? If the answer is it's not very complicated, you don't need this. Don't need it at all. Unless you have specific needs, your application from certain infrastructure features, like, and we'll come to them, confidential compute, for example. Does anyone know what confidential compute is? Gero does. I'll say, I have the microphone. So confidential, encryption at rest is your data encrypted whilst it's stored on a storage account. Encryption in transit, it's being transmitted over a network or a secure tunnel. Encryption while in use, what confidential computing enables, right? And it's a feature of AMD and Intel chipsets. The CPUs, the newer ones, include hardware features to create enclaves where code can execute where it cannot be seen by anyone. Cloud provider, anyone with physical access to the machine, no one, not possible. It is a secure computing infrastructure. So whatever happens on that chip, like encryption being the classic, right? Then that is not, it is secure from being watched happening. So if you have a need for that, then you need specific hardware SKUs in Azure, the confidential computing hardware SKUs that light these things up. You need an SDK for the language tech stack that you're using, and you write code to use the SDK that runs on that compute, and you then have enclave where your super secret code, whatever it does, can execute safely, knowing that primers cannot see it. Only AKS offers that infrastructure. So if that is your application use case, then you need AKS for that, or actually as or just straight VMs.
Yeah.
ACA doesn't support that. And so again, that's the reason, well, business use case, the business say, I needed confidential compute. Business probably wouldn't know what on earth that is. What's confidential compute? Yeah, we want it secure, is what the business is going to want. Technologists like us need to understand what this feature is, how it might be used, and then need to understand, does this particular application, would it benefit from that feature? It might not. No, doesn't need it. It's fine. At rest and in transit is all good. Doesn't, no, super secret, you don't need it. But if you did decide, okay, this one, super special, yep, this one might be a good candidate, up to us to decide that infrastructure needed AKS. Even if it's a small application, which it might be, you need AKS for that. A number of examples like that.
So does AKS has all these, what do you call, ways to find out all the metrics of nodes, CPU?
Yep. So AKS has substantially more features for viewing not just the health of the nodes and how busy they are, but also the traffic between the nodes. So if you've got two different containers, so in my example right there, I had a web app and an API. Well, no, so container apps, there isn't a way to know what the traffic between those two is like. Because the web app's going to be calling the API all the time, right? How busy is that? No idea. How would I find that out? I wouldn't. I can't. I could write some custom code, but really, I can't know that. AKS provides the ability, it has some very strong networking capabilities to allow me not just to understand traffic amount right there, but also to control it if I want. So I can say that these applications on my AKS cluster, they can talk to each other only on this point. These ones, nothing else can talk. So you can secure it, get down, and monitor and view the traffic between everything happening within the cluster. Lots more visibility, and it supports some services that can't they're available. The visualizing sources for doing all the metrics. I've configured in here, but else.
Okay, works cool.
It has container insights, another native feature that is installed on your AKS cluster that knows how to read the logs that your containers spit out, and it will egress them off of the cluster and out into application insights, so your developers can see what's happening in real time on the code of your containers, or near real time, without having to actually get on the cluster and look at the code running in production. So Container Insights has a whole bunch of telemetry and error messages and all kinds of stuff that it just handles. It just gathers for you and surfaces up so your developers can see it. ACA doesn't have that. It also Prometheus and Grafana. So those are two metric gathering and viewing services, open source, native solutions in Azure. AKS has support for those services to get very rich telemetry gathering and viewing capabilities of all of that. Azure Container Apps doesn't have that.
What about Istio? Does it have integration with that?
So what's your question?
Istio?
Istio?
Yeah.
Istio, yep.
Yeah.
So if you would like Istio, you have to install that. Yep.
But you can.
Absolutely. Yeah. Oh, yeah. You can absolutely install Istio. But Azure Container Apps have that natively built in. So AKS has, maybe I'll go back to my slide for some of these.
I think one good observation here is that when you're on ACA, the control plane is covered as part of your service. The AKS, you're paying for your control plane nodes. Like you saw, there's like 32 containers running with just his basic application. With an ACA, it's like 2. 3 copies of it. Right?
Yeah, I only pay for the containers that I run. That's right. With AKS, you pay for the compute, the virtual machines that run the operating system, Linux or Windows, and all the Kubernetes stuff, which is all the containers that Arrow is calling out. So it runs, you pay for that infrastructure to run Kubernetes. You don't get a choice over that. It has to run Kubernetes, which is the orchestrator stuff. And then after it's got all the OS and the Kubernetes on, each of those nodes that you're paying for, whatever's left in terms of memory and compute, that's where your custom application. So and you need to pay for those virtual machines all the time, at bare minimum. So they can't be too small because of the need to run the Kubernetes minimum runtime on it. And whatever space is left, you pay for it until you put containers on it, and then you still pay for it, but now it's running containers as well as everything else.
They have to be dedicated.
Yep, you need, yes, yep. Those virtual machines are dedicated to your cluster, and they're running all the time.
I heard the VM, you can actually, there are some VMs that you can get it when it is like nobody is using.
What is it? Yeah, spot instances. Yeah,
you cannot use it.
Yeah, that's one of these slides. AKS does support spot instances, which are cheap VMs. They are unused, idle. No customer has them. Microsoft lets you have them for cheap until such point as a customer would like it, in which case you're kicked off. That's every act, just thrown off, which is a good use case for Kubernetes because your workload won't fail. Kubernetes will redeploy your workload to another node, right? So yeah, spot instances for Kubernetes are a good way to save money for workloads that are interruptible. But if you want your workload just to keep on running, and not to just suddenly die out of the blue, then you need spot instances aren't for you. So certain use cases for those. Others would be the GPU ones, low cost ARM ones I was mentioning earlier. There's also burstable ones, particular pricing mechanism. It's the same infrastructure. There's nothing special about the infrastructure, but the pricing is such that it has a meter, which if your VM is idle and doing nothing, this meter fills up. If your application does some work and makes the CPU spike, this meter drops. And if this meter drops too far, then you're throttled at 20%. So it supports very idle, that's why it's called burstable virtual machines, because it supports burstable workloads. If you have a workload that is, it goes up even halfway and just stays there using 50%, then you are going to be throttled at 20%, and it's going to be very, very slow. The trade-off is that it's cheap. So again, as technologists, it's important for us to understand the uses of this infrastructure, understand whether the application is going to make sense. Can it use that? Can it use the burstable ones? Can it use the, not burstable, the spot instances you were just asking about?
Yeah.
And choosing those nodes appropriately for our application to maximize cost. None of those features available in ACA. Yes, Paul.
Regarding confidentiality, this may
Confidential.
be the dollar question of the night, but under ACA or AKS, if you've done your application, it's run, you're finished with it, you want to keep everything back at home on the servers. Is there a way of knowing that every trace of it's been wiped out so you can assure your corporate whatever that
Yes, that you would just go into the Azure portal and delete it, right? Your question is okay, how do I know it's been deleted? And there's a portal for the documentation where Microsoft has paid Deloitte, in most cases, to audit the processes that Microsoft actually has to go to ensure that when you just delete something in the portal, it is really deleted.
Because it's, we back up and all that.
Okay.
And knowing that it's wiped out intentionally.
Yeah.
You can ascertain that.
Yes, you can, by virtue of following, looking at the results of audits done in the back, if you will, by independent auditors who have validated that, yeah,
It's good to know.
it's really gone, or whatever. There's a whole slew of them, whole slew of things.
Trust Center is what you're referring to. It's available in the Trust Center.
Trust Center, yes, thank you. The Trust Center, where all kinds of stuff like that. Okay, so there's a whole long list of stuff that ACA has. Sorry, I need to go. You guys, sorry, I went on too long. You guys, you need to go.
Now we sit down.
Okay, you're good.
Yeah.
Okay.
Yeah. I need to go as well. I have some holiday. Just keep going.
You didn't warn us.
Hi.
I mean, you did say in the beginning that this is going to be.
It was
Yeah.
wonderful.
It's all good.
Wonderful.
Thanks for coming out.
Thank
I'll
you.
hope to see you next. We're going to do Elasticsearch. Hope to see you next.
Oh, next month. Yes, absolutely.
I'll keep going for everyone else.
Oh, yeah.
Good to see you. Thanks for coming out. So, one of three, all the services that AKS, ACA does not have AKS. So we're just going to touch upon some of these. We've already spoken about some of them, right? So you can't mount disks to ACA. You can mount a disk of varying sizes and performances to AKS. You can mount Azure NetApp files of very high performance storage subsystem with replication features and a whole ton of features that you can mount to your AKS cluster. Can't do that in ACA. There is a container storage service specifically for AKS, only for AKS, that supports things like Elastic SAN for where you need high performance network shares available to your applications from AKS. You can just have ephemeral storage locally to your container, or Azure files are supported on ACA. That's it. That's it. Which might be okay. Again, your application that might be all right. Which is why it's important as technologists that we understand what Azure NetApp files. Why might my application need that? Because the business aren't going to say that. Technologists, we need to understand what container storage is, what the features that it offers. Well, what is it? I'm not going to answer that now. For the takeaway is that does my application need that? Because the business aren't going to ask for it. They're going to want it cheap, right? They're going to want it cheap and fast and secure. and they want it done right now. As technologists, we need to balance those. ANF is not cheap at all, but it is very, very fast and has some really powerful replication features that might be of benefit. You need to understand. There's various, so Kubernetes has its own role-based access control within the cluster, as well as outside of the cluster. You have the ability to control access to like namespaces, which is a lot of division of services. You can divide up your cluster logically using namespaces, and using Kubernetes role-based access control gives certain individuals access to certain namespaces on that cluster. So you can carve up that cluster securely. So it's a good use case for sharing the cluster or having multiple workloads, some of which might be hostile to one another, potentially. ACA, doesn't, not that. Do you need that? Again, a rhetorical question. Does my application need that level of security within the cluster between application workloads? Do they need to be kept apart? Are they secret? Do the developers of one application, do they need to not be able to see any other applications running on that cluster, or the logs or anything? Do we need to isolate them to just the application that they own? The answer is yes. Then we need Kubernetes role-based access control, Kubernetes namespace features, and AKS. Or remember, Azure Red Hat OpenShift supports Kubernetes, but we've left one out. And a whole slew of other Kubernetes features. I didn't pick on namespaces because I need one. There's a lot more that Kubernetes has, all of which are available in AKS, none of which in ACA. So no Windows containers, no Defender for containers. I showed you that one briefly. No, I didn't. I showed you the monitoring solution. Yeah, Defender for containers is a security solution specifically for containers running on your Kubernetes cluster. Only available on AKS. Omnidirectional compute. I mentioned the ability to visualize the traffic on the network inside your cluster. You can do that. I'll do that in ACA. Application Gateway, we'll talk about that one. That's a separate service that AKS supports. A very powerful security service. Load balancer, not available as part of ACA. That one up, but AKS includes it. And then there's service mesh features, which is similar to Dapper ways, and the software-based technology to make it easier to manage and deploy applications that are microservices. Yes.
We have an online question.
Go ahead.
Mr. Ham, in your opinion, most of the small and medium-sized companies justify the use of AKS for deploying containerized apps, Docker-based?
Do enterprise companies justify the cost of AKS for what?
Guys,
Okay, yeah, I see. Do they justify AKS? Well, that's sort of the crux of the discussion, really, right? If the application needs it, and that's what you need to understand if your application needs. And so this is one slide of features that only AKS has, that ACA does not. So the answer to the question of, do the small and medium-sized companies pay AKS only if they need these features, basically. If they don't need these features or the ones in the next two slides, then they should not pay for AKS. They should pay for Azure Container Apps. Now, many customers actually don't know that Azure Container Apps is a thing, especially if they come from the Kubernetes world, because Kubernetes has been around for a long time in the tech world, 20, right? It's a long time, 9 years. Been around a long time. Container instance, container apps, a few years, 3-4 years, I think, something like that. So much more recent. And so in many cases, Kubernetes has been around a long time. AKS is automated Kubernetes, so it's better than just deploying it on a bunch of virtual machines. So it's better than that, but it is still Kubernetes. So a lot of customers who needed Kubernetes because that's what their application required, still have that. But now, unless they need all these features, they could use Azure Container Apps instead, but they might not know. Go ahead, Michelle.
Yeah, there's the reason why you would prefer ACA over AKS if your solution can run on both. Is it because ACA has lower, than
Yeah. I did the spoiler alert at the beginning, which I was saying that ACA is really the one you want. You want Azure Container Apps, unless you need all these extra features. Unless you need the features of AKS in some regards, some of the things that it has, and you can see there's a lot. We've got 2 more slides of things that ACA doesn't have. So unless you need those features, and you probably don't, usually, then Azure Container, which is another way of answering, the question here, is that many small and medium companies do pay for AKS because they feel that Kubernetes is what they need, and so that's what they've learned.
And disregarding from a total cost of ownership perspective, the management overhead, right? Because that's what we're trying to get away from if we possibly can.
Right.
There is, like in many Azure services that have overlap in functionality, there is, from a pure compute standpoint, there is a break-even point between where the cost savings that you get in ACA versus the flexibility you have in sort of dialing AKS into exactly what you need from a compute perspective. There is a break point where AKS might make more sense from a pure compute standpoint, from a dollars and cents, but that's not taking into account the increased management overhead. That if you didn't need any of these things, and you had nobody on staff who had that expertise, well, then there's a intangible cost to that. It's just
right. Yep. That's right. Hope that answers the question on. Yeah. Okay.
Okay.
All right. Okay. No support for container instances. I mentioned that was one of the container services that isn't the one we're talking about. Container instances is a separate service for ephemeral, individual containers. Comes up, does something, goes away. So you wouldn't run a website on it, for example, leave it running all the time. Azure Container Apps has no support for that at all. It's a separate service. If you want to use that, go ahead, knock yourself out. Azure Container Service, AKS, actually supports having container instances in addition to the VMs that you have. You can have it spin up some container instances and back down again, and your AKS cluster can control that for you. So it is still a different service. ACI, container different service, but controlled for you by AKS for certain. So we talked about application gateway quite a bit. The advanced container networking is the answer to the question about how we see the traffic between our nodes. That's a feature of AKS, advanced container network. Not a network default, incidentally. It's an optional feature, but that's one of the powerful things that if you need that, AKS has that. It's the editing. GitOps is a feature of a way of deploying applications to your AKS cluster that ACA does not support. Azure Container Apps will go and fetch your container from the container registry, and that's it. That's all it will do. AKS will do the same thing. It too will go and fetch the same container image from the container registry. That's what you would like. Optionally, you can enable GitOps, which is where you'll actually read the source code from your GitHub repository or Azure DevOps GitHub enable repo, pull it down, build it, and then deploy it. Well, actually push it to the container registry and then stand all in one go. So it's a pull, the whole pulls and builds, deploys all of it end to end. So for very large clusters where you have a lot of applications, GitOps can be a good way to go if you need that. Signed in security features of container images enabled by the premium tier of Azure Container Registry that only AKS supports. So you can have the ability to sign your images, which makes sure that they haven't been tampered with, And then AKS will check for that signature and not deploy the image if it's not signed. ACA, Azure Container Apps, doesn't care. Signed or not, doesn't care, whatever. So if you like that feature, AKS is what you need. Fleet Manager, separate service that's option for managing multiple AKS clusters. This is the closest to real deployments of containers that you can get. So you can have 2 AKS clusters, 2 or more, different regions, and Fleet Manager, you can have those manage those clusters, so manage deployments to those, manage policies to those, single point of view, making managing a fleet of AKS clusters a little easier. ACA has no such support. You have to manage them all individually. So this Fleet Manager is a better story where you have all AKS clusters all running the same workloads. It's easier to. We talked about Prometheus and Grafana and Container Insights, metrics. There's built-in cost analysis for AKS. There's cost analysis available for ACA. Then it's a little fine-grained in AKS. There's a marketplace for AKS. ACA doesn't have. Finally, there's a AI toolchain operator preview feature that building your AI-enabled apps that ACA doesn't support. Extensions are how you put on this variety of those, including some of the features like Dapper that ACA has out of the box. You want Dapper on AKS cluster used extension, but there are other extensions that you can add in extension support in ACA. You can actually enable host-based encryption support. So you can have the physical hosts where your nodes are deployed encrypted REST in addition to VM storage encrypted REST. So double encryption of your VMs running your cluster for extra security. That's what you would like. Pod managed identities we're talking about. You have user managed identities, which are managed identities, which could be used in the same. Pod managed identities is a way of having identity created per pod. A pod is a deployment of containers to your cluster, and pod managed identities is an identity created for that pod, which can then be given just the permissions it needs to read from. Very automated and scalable way of securing access from your applications to the resources they need. SQL servers, databases, storage, like that. A few maximums, the containers can only go so big. 2 CPUs, 4 gig of RAM is as big as an ACA container can go much bigger than that on AKS, depending on the VM size that you pick, up to VM goes. Giant. Let's look it up. 5,000 cores environment is the most ACA. Quite a lot, pretty big, but you can have a lot more cores than that. With AKS can support 1,000 virtual machines. Virtual machine can have 128 cores each, more than that, depending on the SKU. So really, 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 really big if you need. And we talked about ARM64 support differentiator. If you need that, AKS has that. Again, cheap. The main reason for needing ARM64 support. Okay, and then there's Kubernetes, as I'm trying to say, we said it a few times, it's kind of a lot of work to operate and manage. There's a lot to it. It's a very powerful service. You need to understand Kubernetes. You need to patch it. You need to update Kubernetes. There's a whole thing you need to know that with ACA you don't. That there's a automatic feature. It's actually a SKU. It's a SKU AKS now, which is a lot automated, which makes it easier to use than it used to be. So now it will relieve the burden of managing your AKS cluster, making it less onerous to take on this thing from an operations perspective. So still in preview, but that's a good thing. If you don't have the people on the staff who want to learn how to do Kubernetes and all that care and feeding. I think we talked, these on the previous slides, nodes we talked about. You can have Azure Linux on AKS. Did anyone know there's an Azure Linux? A few people knew that Linux. Azure Linux, Microsoft's own flavor of Linux. It's open sourced, and the reason for it is to control that chain from the open source community. So Microsoft controls all those updates and everything instead of the other Linux options, which is Ubuntu. You can have Ubuntu as their option, which is controlled by the open source community. So,
Is Azure Linux the new branding of what was Mariner before?
correct. Yes, it was called Mariner. That's right. Yep. Azure Linux. Yep. So you want that if you want control over the open source tool chain, and control is Microsoft is still open source, but that is an option for you if you don't want to just get everything from the open source community that Ubuntu put onto that Linux, because that is what you're going to get. You don't get to pick OS that you want. It's Windows or Linux, and it's specific images of that. Microsoft, of course, controls the Windows ones. The open source community controls Ubuntu ones. Microsoft controls Linux ones. So you have that choice if you want it.
I find it odd that it uses the Windows, but you can't have Windows containers
You can. Windows containers. You can have Windows containers, right?
in ACA.
In Azure Container Apps, you cannot have Windows.
Right,
That's
this doesn't make any sense to me.
Linux only.
I mean,
Linux only.
Linux only.
Yes. You can, yeah, you have to write your applications in Linux if you want them to run on Azure Container Apps, which most of them are. Windows containers is actually a pretty small use case. It's uncommon. It's legacy applications, some old junk written back in the day.
That part. So I am in my middle 70s, so,
Okay. Yeah. And way back. We can go way back. Yeah. Some old stuff.
You're good.
Yeah. That we can pack into a Windows container and then we can run it on AKS. Cannot run that on ACA. New stuff, you usually.
75th birthday was Friday, so.
Well done. That's excellent. We can all hope to be so lucky to make it that far. But yeah, that's a differentiator. If you need Windows, then you have to use AKS. But usually you don't need Windows. Linux is the common. Okay, capacity reservations. You can save money by paying ahead of time for your compute for AKS. You can't do that with ACA. Talk about container indices. Whole slew of VM choices to pick from. There's burstable ones, the spot ones. There's just an array of compute to choose from. Don't get any to choose from ACA other than with GPUs. And there's a public roadmap. So an absolute ton. We're nearly there.
And Adam, I apologize, but I'm not sure how long he's had his hand up, but Harmeet's had his hand up.
Oh, okay. Missed that. Hey, Hamid, you can come off mute and
No biggie, Adam. You can hear me good?
just about.
Okay. Well, so
Yeah.
I was waiting for the 3 slides to be completed. Let's run a hypothetical scenario, architecturally. I do not need any of those features. I have about 50 applications.
Okay.
They're going to be used by about 10,000 users.
Mhm.
And I know load-wise, at max, I'm going to have a few applications, so I could have 400 concurrent users, period. Not on all of them. That's the max. Now, would I even bother trying to do this using ACA with multiple instances based on the sizing of the nodes that you provide?
Yeah. So if the maximums of ACA number of cores meet your need, also the number of instances that you can have per subscription, right? Because you might well need multiple ACA points. Yeah. So look at the documentation, look at the maximums of those per subscription, might be per region as well. If you are able to use Azure Container Apps to host many of those, to host your applications, then that is preferable to having AKS if you don't need the features. Because the ops and maintenance of even lots of ACA clusters is very, very small. It's a very automated service, right? You don't need not a lot of care and feeding. AKS does require a lot of care and feeding. So really the fewer clusters you have, the better. Now that's where Fleet Manager helps a little bit when you've got lots of clusters, but you really don't want lots of clusters unless you have for each cluster a team that manages it. So that's not your use case, but that's what we see at large enterprises. They'll have lots of AKS clusters, but each one will be managed by their own dev team or dev teams. In your case, if you're managing all of these clusters, you don't want lots of AKS clusters. You could have one honking great AKS cluster with everything on that. This, again, look at the limits. AKS goes pretty big. That might be a scenario for you. That might work if you needed the AKS features. Look at the prices, but you might, for example, at that scale, be able to take advantage of some of the pre-purchase options for AKS, right? You can pre-purchase the virtual machines in order just to make it cheaper. Or those AMD 64 nodes, for example, to reduce your costs. So a huge fleet, low-cost compute infrastructure, and then load it up with all of, because it will host lots and lots of applications, right? Many thousands of containers. Again, look at the limits for AKS to see if that fit. And if it does, then managing one AKS cluster, even an absolutely colossal one, is not much different to a small AKS cluster, really, because the same set of features and needs and maintenance and monitoring still apply. You just more stuff to look at, really.
So, Adam, I was just trying to confirm, if I have that 50 application scenario, I know that there's 50 apps. Should I even consider looking at?
You consider what, sorry?
Should I consider
Someone's on a mute. Yep. Where's the Kimber? Did she go? She had to leave. Oh, okay. All right. Yeah. We'll repeat the question.
Yes. So I was just confirming with you, if I have a set scenario of 50 applications, max 10,000 users, most concurrent at any time, let's just say hypothetically for 5 of the 50 apps, 400 users at any time, not more than that. Should I even try to consider doing these deployments with ACA? Or should
ACA, yeah, ACA was to that. Yeah. ACA is pretty big.
Yeah. Sure.
Yeah, yep. Users, yep. I mean, really, it's about the compute, right?
Because I am in line with the other gentleman that previously spoke, because I can only see part of the screen right now. It was on the other side, where you need dedicated personnel with a lot of knowledge to manage AKS as it scales.
You do. That's correct. You do.
Thanks for answering the question.
Yep. Yep.
Yeah, because we work at the same company, and we are. Correct me if I'm wrong, Harmeet, but we're hosting like almost all of our. He dropped, but we're hosting like almost all of our Azure applications in the same Kubernetes cluster.
Okay, you can. That'll work.
And it's managed by. There's only one person who knows Kubernetes, and he's a contractor.
That's bad. Jeez.
Yeah.
Yeah. Contractors. Yeah.
Great.
Yeah.
So I think he's trying to see like, would it make sense to like create one Azure Container Apps environment that you put
all of it on? Yeah.
Okay.
Yeah, you can do that. Yeah. Yeah. You may wish to have multiple, right, depending on your application needs. But
Private networking is going to drive something like that sometimes, because private networking is at an environment level. So if you had different groups of apps with different private networking requirements, that might be one thing that drives you to that distribution. But assuming we're talking about an enterprise, not like a public facing.
Yes. Yeah, but ACA, you definitely look hard at that, because you don't need anyone with Kubernetes knowledge at all. Zero. They don't need that. Okay. Let's see. Other considerations, the pay-per hour, no previous queues. What else? Is there anything I talked about the steep learning curve? I think we might have talked about all these things. And then I had a summary here, I think most of which we've already talked about, right? In our conversation. Skill level, the customization you need, whether you need the features of AKS, and if you don't use, don't go with AKS. You don't. There's no points for having that. Don't go for complexity you don't need. And in some cases, nothing wrong with web apps for really simple applications. They're okay. Really simple applications that aren't going to grow and need more later. I think that was it. The next slide, but yeah, that was it. That took a while, but we had a lot of good questions. I'll pause for any more for the few remaining. The keen that's still here. Oh, did you got them all out as we went through? Yeah, go ahead.
You know what the topic is for next month?
Yes, we're planning on having someone from Elastic. They have Elasticsearch, which is a native parse service in Azure. Come in and tell us how that works, why you would want it, what it's good for, show and tell. All things Elasticsearch. What is it? Why it's awesome. Good question. Okay. In that case, we'll close it out. Thanks everyone for staying with me. I enjoyed myself a lot. So.
As long as you had fun.
Great time. Thanks all. Hope to see you all next month.
Yes, thank you.